Bismillahirrahmanirrahim. Dear students, this is Dr. Muhammad Shafiq again, and I'm the lecturer of philosophy at the Department of Islamic and Pakistan Studies Trust. The course I'm teaching is called Introduction to Logic, and the course code is PHI 101. This is lecture number 20, and in this lecture, today we are going to discuss what is meant by Venn diagram and what is syllogism, or what is the role of Venn diagram in syllogism. The outline of today's lecture consists upon two parts. The first one, we are going to discuss what is meant by Venn diagram, and the second part of this lecture consists upon how we can use Venn diagram for testing our syllogism, or testing the validity and invalidity of categorical syllogism by means of Venn diagram. So let us start. First of all, we need to have a look at the Venn diagram. What do we mean by Venn diagram? There was an English logician whose name was John Venn, and he basically popularized the diagram in 1880s. He called these diagrams as Eulerian circles, after naming it after the Swiss mathematician Leonhard Euler, who used and who created similar diagrams in 1700s. So when John Venn basically tried to use the same diagrams, and hence he named it after the mathematician who created these diagrams, Leonhard Euler, as Eulerian circles. Venn diagrams are principally used to depict how items are related to each other against an overall backdrop, universe, dataset, or environment. A Venn diagram could be used, for example, to compare two companies within the same industry by illustrating the products both companies offer, where circles overlap each other, and the products that are exclusive to each company, that is the outer circles, which do not overlap or touch each other. A Venn diagram is an illustration that uses circles to show the relationships among the things or groups of things. A Venn diagram uses circles that overlap or do not overlap to show the commonalities and differences among things or group of things. So if circles overlap each other, that means they have an integrated relationship with each other. If they do not overlap, that means they don't have any relation which is integrated. Things that have commonalities are shown as overlapping circles, while things that are distinct, that are not integrated, and they stand alone, or shown with different circles. Venn diagrams are now used as illustrations in business and in many academic fields. And this is a very convenient way to use as illustrations in different settings, in different fields. Hence, the Venn diagrams are very useful to make complexities, to avoid complexities, to make complex things very simple in terms of circles. So a Venn diagram could be drawn to illustrate fruits that come in red or oranges, for example, orange colors, for example. If we closely look into this figure, we can see that there are orange fruits, so such as persimmons and tangerines, while apples and cherries, circle A, come in red color. Peppers and tomatoes come in both red and orange colors, as presented by the overlapping area of the two circles. So the circle A, the part of the circle A which do not overlap circle B, that basically depicts apples, cherries, which are in color red, while circle B, the portion of circle B which is not overlapping circle A, depicts persimmon and tangerine, which are of orange color. And those fruits which are basically which share the qualities of both circle A and B, they are shown in the area of those circles which are overlapping each other. Now in Venn diagram, the Venn diagram, when using it for the categorical proposition, is shown like this. For example, the proposition is a universal affirmative proposition depicted by A. If it says all S or P, S is depicted, it is a symbol for subject, while P is a symbol of predicate, letter for predicate. So if we say all S P, that means all men are mortal. So we show that we will draw two circles, circle S and circle P. So when we say all S is P, that means the P the whole portion of P is the part of S. So we are going to shade the portion, the area of S which is not integrated, which is not overlapped with P, because that shading would say that there is no S which is the part of P. So the only part of S which exists is the part of P. Hence, all that part which is a part of S which is not overlapping P should be shaded, and that means it is empty or it does not exist. In the second instance, if we take the example of universal negative proposition, which is depicted by letter E, again we will draw two circles, and if we say no S or T, that means no men are stupid, for example. So that means that class of S or class of men is entirely different. It does not share anything with the class of P, which is stupidity. That means that both classes are different. So again, drawing those two circles overlapping each other, we need to shade the overlapping portion of these two circles, because these two circles do not share anything at all. So shading would mean that this portion does not exist. So S is entirely different class than P, and both are separated with this shaded portion. The third example of particular affirmative proposition, it says that some men are intelligent. That means that basically by some of that particular group, we mean at least one member is as such, which, which is basically the member of both classes. So when I say some men are intelligent, that basically means at least there is one man who is intelligent. So in this case, again, drawing these two circles overlapping each other, we need to put a cross between these overlapping circles, the area or the portion which is shared or overlapping both. And we need to put X, that means there is at least one member or one object which is basically the member of both classes. So we show it with the cross. The fourth mode of categorical syllogism is particular negative proposition. If I say that some S is not P or some men are not intelligent, so that again means that there is at least one object which is a member of S class but not member of P class. At least there is one man which is, although being a man, is not intelligent. So drawing these two circles again, overlapping each other, we need to put a cross in the portion of circle S which is not shared with P. So there is at least one object which is the member of class S but is not a member of class P. So that is how we show or we depict our propositions, categorical propositions in terms of Venn diagram. Now, how do we test syllogism with Venn diagram? So far, we have seen that there is Venn diagram is basically used in different academic fields, and then we also had a look at how Venn diagrams depict categorical propositions. Now we are going to look deeply into how we can test syllogism with the help of Venn diagram. As there are three propositions in categorical syllogism or any kind of syllogism, that means we need to draw a circle for each proposition. So, in case of syllogism, we need three circles, three overlapping circles. So that would basically depict our categorical syllogism. Now, three circle diagrams with each circle intersects or overlaps the other group are used to represent categorical syllogism, a form of deductive argument consisting of two categorical premises and a categorical conclusion. A common practice is to label circles with capital and, if necessary, also lowercase letters corresponding to subject term of the conclusion, the predicate term of the conclusion, and the middle term which appears once in each premise. If after both premises are diagrammed, the universal premise first, both are not universal, the conclusion is also represented. The syllogism is valid. That is to say, its conclusion follows necessarily from its premises If not, it is invalid. If you remember, we had already discussed in different forms of argument, different kinds of argument, that all those deductive and inductive arguments. If you remember, we discussed it in detail. So, deductive arguments are those arguments in which if premises are true, conclusion is true, that means premises support conclusion conclusively. So, syllogism being a deductive argument says that if both premises which are diagrammed in this Venn diagram are true, the conclusion will also be true. It must be true. And if it's not true, then our syllogism would not be valid. So the conclusion must necessarily follow from its premise. Now, let us try to depict this argument in terms of Venn diagram. So, the first premise says that some mammals are carnivores. Second premise says that all mammals are animals. And the conclusion says, therefore, animals are carnivores. To diagram the second premise, for example, which is because it is universal. So, it does not matter if it is first premise or second premise. If it is universal, it must be diagrammed first. So, we will draw three overlapping circles, and the universal affirmative proposition, which is the second premise. First, we need to diagram this one, and which says all mammals are animals. That means all the members of mammal class are the part of animal class. Hence, all that portion which is not shared between class of mammals as M and class of animals depicted by A. If there all mammals are animals, that means there is no member of mammal class which is not part of animals. So we have to shade all that portion of class of circle mammal which is not the part of circle animal. So we have to shade that to show that it does not exist. So only that portion which is shared by class A and M is left empty. The first premise now, which is particular affirmative, then we need to draw this diagram. And if you remember, as I said to you earlier, that when you say some mammals are carnivores, that means at least one member of mammal class is part of the class of carnivores. So we need to put a cross in the portion which is shared by mammals and carnivores. So we put cross in that portion. And the conclusion is left like that. So to diagram the second premise of example, which because it is universal universal must be diagrammed first. One shares the part of M members that does not intersect animals, class A. To diagram the first premise, one places an X or cross in the section of M and C. Importantly, the part of M that intersects C but does not intersect A is unavailable because it was shaded in the diagramming of the first premise. Thus, the X or cross must be placed in the part of M that intersects with both A and C. In the resulting diagram, the conclusion is represented by the appearance of an X in the intersection of A and C. So the syllogism is valid. Therefore, some animals are carnivores. That means at least one member of animal class is also part of class of carnivores. And if you look into this diagram, there is a cross in the portion which is shared by C and A. That means this syllogism, categorical syllogism, is valid. Now let's try another one. Some sages are not seers. No seers are soothsayers. Therefore, some sages are not soothsayers. Again, we draw the three circles, and the first, again, we need to draw the diagram for the universal proposition, which is the second premise, universal negative. So that says no seers are soothsayers. So the class of seers and class of soothsayers do not have any commonality. So we need to shade all that portion which is shared by the class of seers and the class of soothsayers. Secondly, then we try to, some sages are not seers. That means that we need to put a cross between the class of sages and seers because there is no such, there is at least one member of class of sages which is not the part of class of seers. So that means that the class of sages and the class of not seers, we put the cross on the line. To diagram the universal premise in syllogism, one shares the part of soothsayers that intersects. So soothsayers, to diagram the particular premise, one places an X in sages on the part of the boundary of so that does not assign a shaded area, which by definition is empty. In this way, one indicates that the SA, that is the class of sages, is not an SE, it's the class of seers, may or may not be on an SO, that is the class of soothsayers. The sage that is not a seer may or may not be soothsayer because there is no cross that appears in SA and not in SO. The conclusion is not represented and hence the syllogism is invalid. So this is how we basically try to test our syllogism with the help of Venn diagram. I understand this is quite complicated, but if you try to listen to this lecture a few times and if you try to look into the books which are referred here and which you can find in the library easily, I hope you will be able to understand this properly Uh, if not, or if you have any questions or queries, please do let us know so that we can discuss it in our lecture. Till then, take care and Allah Hafiz.